morning, all of you. In this session, we are going to discuss about how the polymerization of polymers are possible starting from the monomeric units. Mechanism of polymerization is going to be discussed extensively. So in addition to this, we already completed introduction to this polymer in the earlier session, and all the solved question papers of CSIR and the entire detailed explanation for engineering chemistry topics like water treatment, molecular structure, stereochemistry, electrochemistry and corrosion, spectroscopy, all 10th class physics and chemistry topics available on the channel called World of Competitive Chemistry. Now we are going to enter into the concept of how the condensation as well as addition polymerization get carried during the polymerization starting from the monomeric units. So let us enter into our today's session. Here, the topics going to be discussed today are types of polymerization process. So this is the extensive topic going to be discussed. We already completed what is polymer and the classification regarding the polymerization. Now let us see what is meant by degree of polymerization first. Degree of polymerization denotes what? Number of repeating units in the polymer formation is denoted as degree of polymerization. I'll give the simple description for this one. Degree of polymerization where, for example, we are taking polyethylene formation. In that polyethylene formation, if polyethylene formed by the repeated combination of 200 units. So here, degree of polymerization for that polymerization is denoted as 200. dP is regarded as 200 because degree of polymerization is nothing but how many number of monomers involved in this polymerization process. Degree of polymerization provides indirect method of expressing molecular weight because based on number only subsequent molecular weight remains. That's the reason why this used for the quantification of polymer formed. So because polymer is a huge molecule that will be formed by number of monomers units we are adding, we are interconnecting, right? So in that manner, how many monomer, that quantity is required in order to mention the degree of polymerization. That's the reason why subsequent molecular weight calculation is possible. Here, M is equal to dP into small m, where capital M denotes what? Molecular weight of the polymer. Capital M denotes molecular weight of the polymer taken. Degree of polymerization is denoted with dP, and small m denotes what? Molecular weight of the monomer taken. For example, monomer molecular weight is 50. We are adding 200 units. 200 into 50 will become the molecular weight of the given polymer. So the polymer form. In this manner, molecular weight of the polymer can be calculated. It will be calculated by knowing this degree of polymerization for the given polymer, right? Degree of polymerization is equal to sigma Ni dpi by sigma Ni. Sigma denotes what? Combination. It will be the sum of the numbers. So and dpw is equal to, so here degree of polymerization in terms of number, degree of polymerization in terms of weight can be taken. Degree of polymerization in terms of weight is equal to sigma Ni dpi whole square, sigma Ni dpi. So this will be the formula in terms of weight. So here number of, if we are measuring number of monomers involving the polymerization, that denoted with N. If you are measuring weight of the monomers involved in the polymerization, that is denoted with W. Right. Each of these averages can be related with the corresponding molecular weight average by following two equations. Number average molecular weight is equal to dPn into small m. Capital M denotes what? Molecular weight of the polymer. Small m denotes what? Molecular weight of the monomer taken. And dP denotes what? Degree of polymerization. How many units are involving? Right. So weight average molecular weight can be calculated by taking dPw into small m. dPw denotes what? Weight of the monomers involved in the polymerization. In this manner, number average and weight average molecular weight of the given polymer can be calculated. Degree of polymerization is simply given by the ratio is MW by MO, right? MW by MO. MW denotes what? It is the average molecular weight of the polymer. MO denotes what? The molecular weight of the repeating units of monomer. molecular weight of the repeating units of monomer. W denotes average molecular weight of the polymer, and O denotes average molecular weight of the repeating units involved in the monomeric unit, right? So in this manner, degree of polymerization is the ratio calculated by MW by MO, or else it can be calculated by taking sigma NIDPI by sigma Ni. N denotes what? Number of units involved, and degree of polymerization by sigma N. Right, so this is a way of calculating degree of polymerization. And the next topic is about how the monomers get combined to give the polymer. What kind of mechanism involved in this, and what's the chemistry behind this process? In order to explain this one, we have two kind of streams. One is called addition polymerization. The second is called condensation polymerization. Right. So here, either of the way can be followed in order to get the monomer into a polymer formation. Addition polymerization, generally one kind of monomers get involved. For example, polythene, all the entire polymer got generated by the repeated combination of ethylene, same kind of monomers, one type of monomer we are involving. That's the reason why addition polymerization basically consisting one kind of monomeric unit, whereas condensation is nothing but two different units involved. For example, one is hydroxy compound and either is carboxylic acid. Both the monomers are different in nature. That's the reason why two or more different monomers, when combined, that is the process of condensation. Always addition required, not always, in most of the cases, addition polymerization requires one kind of monomer, whereas condensation involves more than one type of monomer during the polymerization process. Polymerization does not lead to the loss in the smaller units. Addition means adding only, no subtraction, no elimination process. That is called addition polymerization. And whatever monomeric molecular weight will be there, and summing all these will give the exact integral of the final polymer generated over here. Whereas condensation polymerization leads to the loss of simple moieties like water, HCl, etc. Some of the byproducts will be removed. That's the reason why molecular weight is not integral. Some of the old monomeric units, there is a decrease in the molecular weight of the polymer when compared to the monomeric units, because we are losing some of the byproducts over here. In case of addition polymerization, empirical formula is the same as that of monomer. For example, if you go with polythene, polyvinyl chloride, Teflon, all these are the categories considered as addition polymers and generated by repeated combination, so that whatever the monomer skeletal structure is there, that resembles in the polymer. And what we have to do, whatever pi bonds are there, double or triple bonds are present, they will be replaced with the continuation of the chain. They are interlinking with any other monomer. In that manner, the chain extension will be possible, so that your empirical formula remains same. We are not supposed to change the empirical formula, but only the pi bonds will be extending the polymeric chain length. But in case of condensation polymerization, we are losing some of the unit. That's the reason why empirical formula will not be same for monomers and polymers. And here are the suitable example for condensation polymerization at nylon 66 and bakelite. Right, so here addition always units get attached and interlinked to each other, and they get propagating in such a manner so that molecular weight remains same and empirical formula remains same, and basically they are made up of same kind of monomeric units, and that will having soft flexible properties. Whereas condensation polymerization, more than one kind of monomers will participate, and byproducts will be generated along with the main product polymer we are expecting for, and the empirical formula will not be same as starting materials, and strength of these condensation polymers are considerably high. And next is about addition polymerization. How can we see what is the process of this addition polymerization? This detailed explanation is going to provide it here. I'm taking the simplest example, formation of polythene. In order to get this polythene, we are taking the starting material ethene, where carbon-carbon double bond is resided in between the two carbon atoms, and this will participate. A number of these units get polymerized in such a manner so that polythene formation is possible. In order to get this, we are taking the starting material of ethylene. This is called a monomer. and the reaction will be proceeded in the 3 different steps. One is called initiation, second is called propagation, third is called a termination step. Initiation is nothing but where the reaction gets started. Starting of the reaction is called an initiation step. Propagation is nothing but continuation. Where the reaction get propagated, continuated, repeated for several times, that is called a propagation step. Termination denotes where the completion of the reaction is possible and the final product of the polymer we are expecting will be obtained, that is called a termination step, right? In order to get the addition polymerization, here the basically 2 types of mechanisms are possible. One is either free radical mechanism, other one ionic mechanism. Free radical denotes what? Whenever the bond present in the compound will be fragmented equally, homolytic fission we can say, so that here free radicals, equal electron containing species will be generated. This will initiate the reaction. Basically free radical mechanism initiated by hydrogen peroxide, and any alkyl peroxide can be taken into the consideration. That will generate OH free radical, or electron containing species is designated as a free radical. This OH free radical will attach to the carbon so that one of the double bond will break equally, called a homolytic fission, so that here one side of you can attach this OH group, in either side one of the electron pertaining on the carbon terminal center, right? So in this manner, the reaction gets started. The step is called initiation. And in the continuation of the reaction, we have to add one more monomer over here. One more alkene compound will be added to this generated active center at the terminal compound called a free radical. So whenever another monomer is added, here carbon-carbon new bond formation is possible and the extension of chain length is possible. Initially, we have only 2 carbons. After the addition, it will be converted into a 4 carbon containing chain with the terminal free radical center. Right. So in this manner, the reaction got initiated by taking hydrogen peroxide or any alkyl peroxide. Because of carbon-carbon direct linkage, it will be highly unstable. Will be cleaved in homolytic fission manner, so that alkoxy free radical is generated. This alkoxy free radical will further reacted with the carbon-carbon double bond, so that here oxygen carbon bond formation is possible, and the terminal center will be originated as a carbon free radical. This will be the active center for the continuation of the reaction, where carbon free radical will be further reacted with the carbon-carbon double bond, so that here carbon-carbon linkage is possible and the bond will be cleaved equally, equal sharing of electrons, which is designated as the homolytic fission of the bond, and a new carbon-carbon bond by the extension of the chain, and again it is persisting this carbon free radical in the terminal center. So this will be continued for several times till the expected chain length is achieved, so that here carbon free radical further added with one more carbon-carbon double bond, so that we can increase the chain length. If n number of such carbon double bond olefinic linkages get added over here, and expected chain length is obtained. For example, if you want to prepare the chain length of 200, here what we have to take 200 monomeric units are required to add, and you will get the n is equal to 200 for this polymeric chain formation, and the till active center will be there in the at the end. So here in this manner we are propagating, we are extending the chain length over here. That is the reaction called a propagation, simply called a continuation of the chain length. And the termination is nothing but where you want to stop the reaction, where the completion or breaking the reaction is possible. That is designated as a termination step. In order to terminate the reaction, we are having carbon free radicals and the end carbon atoms, and these carbons will participate in the coupling reaction. Both get combined by the sharing of electrons, so that here extended chain length will be obtained where the reaction got completed, called terminated. This is a process involved in the free radical chain polymerization, and you will get addition polymerization in this manner by the initiation of hydrogen peroxide or any alkyl peroxide can be taken into the consideration. So in addition, we also have another kind of mechanism called cationic and anionic polymerization as well. Here only free radical mechanism was taken into the consideration for an addition polymerization. And another kind of mechanism which was broadly classified over here called the condensation polymerization. This condensation polymerization is possible whenever 2 active functional groups in the terminal center are combined in such a manner by the elimination of smaller byproducts, either water, HCl, ammonia, any such kind of smaller moieties will be removed, and a formation of the neither functional group is possible by this condensation polymerization. Condensation, alternatively known as step growth polymerization, because the reaction proceeded with step-by-step mechanism, and catalyst is required to augment the rate of the reaction over here. Step growth polymers are also called as condensation polymerizations, are made by combining two molecules by removing the smaller molecule. And this requires the rising temperature. And examples considered under this category are polyester, polyamide, formaldehyde resins. All these are the simple examples of condensation polymers. We are taking here carboxylic acid and one terminal, any other terminal composed of NH2. So this is called amino acid. Already we are very familiar for proteins in our body. Proteins are very essential for the growth of the cells and also growth of the living organisms as well, right? Here, so many kind of proteins are available, and which are formed by the interlinking of amino acids. Amino acids are composed by carboxylic acid and the one terminal center, and another amine and another terminal center. These amino acids are two types. One is called essential amino acids, second is called non-essential amino acid. And essential amino acids are nothing but which are not present in our body, required from the outside through the diet. Those are called essential amino acid. Non-essential in the sense our body is able to synthesize themselves, which are called non-essential, need not to take from the outside source. Those are called non-essential amino acids. So two kinds will be available, but these amino acids are very essential in order to manufacture these proteins, which are called building blocks of living organisms. How the building constructed by the bricks, in the same manner proteins are constructed by the repeated combination of these amino acids, right? And again, amino acids classified into three types, like neutral amino acids, acidic amino acids, basic amino acids. Neutral amino acids are nothing but number of carboxylic acids, number of amino groups in the given compound are exactly equal. That means neutrality will be there. Neither acidic nor basic compounds are designated as a neutral. Acidic in the sense more carboxylic acid moieties, less amino moieties present in the given amino acid chain, they are called acidic. Basic in the sense more amino moieties and less carboxylic acid are called basic amino acids. Three kind of amino acids are available, and all are participating in this kind of condensation polymerization. In order to condense, what we have to do, we have to arrange the molecule in the synchronized form. Synchronization is nothing but suitable to remove the moieties from the terminal center is called synchronized form. And here carboxylic acid and here amino group will be there. They are used to condense in such a manner removal of water molecule is possible. That's the reason it is called condensation, so that here C double bond were directly attached to NH. C double bond or NH, this group is specifically designated as a peptide bond. So here peptide bond will be generated, and this terminal again have active center. This terminal already have active center. They will continue with the addition of a more number of amino acids further, so that here more number of such C double bond NH groups will be generated in both the sides. The chain will be extended in both the sides because both the terminals are having active center. That's the reason why the growing chain will be designated as a polypeptide. Polypeptide is called as protein. So this is a natural polymer available in our body, which is formed by such kind of repeated combination of amino acids. So many type of amino acids will be there. They will condense in such a manner, so proteins will be generated along with the byproduct of water, because hydroxyl and proton will be combined to give the water as the byproduct, right? So here you may take hydrogen over here. If hydrogen was taken, that is called a glycine, and if methyl group is called alanine, and if you insert any kind of alkyl group over here, different kind of amino acids will be originated and different kind of proteins will be there. And by this we completed the mechanism of polymerization. Let us recall in brief today's topic, what we discussed in this session. And today's topic we discussed about how the polymerization process get carried either by addition or condensation polymerization. Prior to that one, we discussed about what is degree of polymerization, what is the significance of that degree of polymerization, how it will be useful in the calculation of molecular weight of the polymer. Right. So here degree of polymerization followed by mechanism of polymerization, that is by addition and condensation polymerization. Addition polymerization consisting in initiation, propagation, and termination. Initiation where the reaction gets started, propagation where the reaction is progressing, termination where the reaction got retarded, stopped. Right. So here in that manner, the polymer will be generated, which is the exact integral multiple of the monomeric units without any loss of side chains or subproducts. But in case of condensation polymerization, we are combining two different monomers. That's the reason why the polymer generated is called a copolymer. Copolymer is nothing but if the polymer generated by the different monomers upon combination is called a copolymer. So most of the condensation polymerization will give the copolymer by the repeated combination of different monomers, right? So here polyesters, polyamides are the simplest examples in this category. And we already gone through the synthesis of protein starting from amino acid as a starting material. By this, we completed today's session, the mechanism of polymerization. Thank you very much for your consistent listening. Hope this session will be helpful for your preparation. Thank you one and all.